Welcome again to Advanced Functions MHF4U1. This is under a Trigonometric Functions chapter. In this lesson number 5, we're going to explore the graphs of a reciprocal trigonometric functions and determine their key characteristics. First, we are going to take a look at our first reciprocal function of sine, which is cosecant function. So cosecant function, represented with CSC as a symbol, is equal to 1 over sine. So as you can see on the graph, you have a sine graph. So the key 5 points that we studied before, 1, 2, 3, 4, and 5. Now what we're going to do, we are going to take the reciprocal of the y values. Now as you can see at 0, 0, if I were to take the reciprocal of my y value, it's going to be 1 over 0, which is undefined. It does not exist. So therefore, all the x-intercepts are going to be represented as an asymptote. So asymptote at 0. We also have another asymptote at pi and another asymptote at 2 pi. Okay, next we have another point over here at pi over 2, comma 1. Now I'm going to take the reciprocal of 1. It stays as 1, so it stays the same. Okay. And then if I were to take the reciprocal of this one, so this, let's say at pi over 4, let's say it's around 0.75. So if I were to do 1 over 0.75, then you get 1.33. So it comes over here. Okay, and then same thing, because it's symmetrical, like this. So as you can see, if I were to take the reciprocal of, for example, all the points in between pi over 4, it's going to get higher. Okay, so as you can see, the curve is going to be a U shape, but upside down. And I'm going to draw the arrow over here. So the points are going to get really, really big, but it will never, it will reach the asymptote, but it will never touch it. Okay, same thing at pi. So the numbers between 3 pi over 4, if I were to flip it, so let's say a point over here that is very, very close to 0.1, if I were to do 1 divided by 0.1, you're going to get 10. So the numbers will become very big, but it will never touch the asymptote. Same thing, reciprocal of this one, we have 3 pi over 2, comma, negative 1. If I were to take the reciprocal of negative 1 over 1, it's just same as negative 1. Same thing. So then if I were to take the reciprocal of a point over here at negative 0.75, you get negative 1.35 around here. Okay, so then another curved, that line looks like this. Okay. So it will be same thing as we go back and forth by the asymptote happening every pi. This is a picture of a cosecant function. So as you can see on the graph on the left, this is what we just drew, which is in red pen. Okay. Now, so let's identify the characteristic of cosecant. Domain. Domain is that x can be any real number, except there is a vertical asymptote at every pi. So we could say domain x can be any real number, but such that x cannot be pi h. Okay, assuming that h is an integer. is any integer. Okay. For range, R. For range, y can be any real number, but keep in mind it has to be greater than 1 or less than or equal to -1. So we say y can be any real number such that y, so there's two scenarios. Y could be less than or equal to -1, or y can be greater than or equal to 1. And that's it. Now, is it even, odd, or neither? Now, so in order to figure out even, odd, or neither, what you can do is you could figure out by looking at, is it symmetrical through the origin? So for odd function, it's the origin. If it's even function, it's symmetrical through the y-axis. So as you can see, it's symmetrical through the origin. You can flip once and flip it again. Okay, so it's a odd function. Vertical asymptote, yes, there is. So in this case, the asymptote occurs at x is equal to pi over h, assuming that where h is an integer. Okay. Now, are there any horizontal asymptote? No, there is no horizontal asymptote because, as you can see, the graph is just approaching the vertical line. There's none. Maximum and minimum. So as you can see, the maximum, the graph is going to keep going up, and the minimum, the graph is going to keep going down. So therefore, there are none. Period. So it seems like one full cycle happens every 2 pi, one going up and one going down. So we say 2 pi. Next, we have a secant function. So secant function is a reciprocal of a cosine function. And the symbol is SEC, secant. So in front of us, we have a cosine graph. Okay. So same thing, we are going to reciprocate the y value. In this case, the reciprocal of 1 is just 1. And then keep in mind all the x-intercepts, which is 0. If I were to reciprocate that, it's going to be undefined. So at every x-intercept, we have a vertical asymptote. And then all the maximum and minimum, the position are exactly the same. Okay. And then now, so what we're going to do, we are going to flip, let's say, at pi over 4, it's about, let's say, 0.75. If I were to do 1 divided by 0.75, then you get 1.33. So it's about here and here. So as you can see, it's a curved graph again that looks like this and like that. And same thing for this one. If I were to reciprocate this point here, and this point comes all the way here, and it's approaching the asymptote, like this. And as you can see, for this one will be like that. So as we can see from the previous example, it's very similar to the cosecant graph. What you will notice that there is a shift, phase shift. Okay, so the red graph, y is equal to secant x. Okay, now let's identify some of the characteristics of the secant function. So domain, it looks like x can be any real number, but except where the asymptote is. So the vertical asymptote happens every pi over 2. Domain, x can be any real number such that x cannot be pi over 2h. Now we have to write assuming where h is the integer. And for range, it looks like y can be any real number, but same idea, y has to be greater than or equal to 1 or less than or equal to -1. So y must be less than or equal to -1 or y must be greater than or equal to 1. Now is it even, odd, or neither? As you can see, it's symmetrical through the y-axis. So therefore, it's going to be even function. Vertical asymptote, yes, there is a vertical asymptote at every pi over 2 and 3 pi over 2. So x is equal to pi over 2h, assuming that where h is the integer. Now, horizontal asymptote. There are no horizontal asymptote. Maximum, minimum, there is no maximum or minimum because the graph is keep going up and down. So there are none. Period. So as you can see, the period, it's happening every 2 pi. So this, starting from 0, 0, this repeat is going to, this pattern is going to come back at 2 pi, right? So therefore, period is 2 pi. Same thing as a sine and cosine graph. Lastly, we have a cotangent function. Cotangent function is a reciprocal of a tangent, and the symbol is represented with COT. With cotangent, there's another way to represent, because we know that tangent is sine over cosine. So if it's reciprocal to the tangent, then all you need to do is flip it. So it becomes cosine over sine. So right in front of us, we are given a tangent graph. Same thing, we are going to flip, take the reciprocal of all the y values. Identify all the x-intercepts. So in this case, at 0, 0, we have our vertical asymptote. And then, let's say for example, if I were to flip the y value at negative pi over 4, so it's at -1, -1 stays the same, and pi over 4 at 1 stays the same. What about when it's at right in between pi over 4 and pi over 2? We have 2. If I were to take the reciprocal of 2, it's going to become 0.5. So it's coming here. If I were to take the reciprocal of the y value between 0 and pi over 4, so we have 0.5 here. If I were to do 1 over 0.5, I get 2. Now, so as you can see, it looks like it's going to be going this way. Okay. Now, until we meet, there is another vertical asymptote at pi. Okay. So then therefore, so as you can see, there is a vertical asymptote at pi over 2. So if I were to take the vertical asymptote, which is undefined, and take the reciprocal of that, it actually becomes 0. Because it's now gonna become 0 over 1. 0 over 1 is 0. So we have a x-intercept at pi over 2, and then the reciprocal of this one, it's gonna turn like this. Same thing, for our tangent graph, we have a vertical asymptote at negative pi over 2. So the y value in this case is undefined, technically, which is 1 over 0. But if I were to take the reciprocal of 1 over 0, becomes 0 over 1, which is 0. Okay. So then it's going to go down this way, same pattern, and it's going to go up this way. Okay. So this is the graph of a cotangent. Okay, take a look over here. So y is equal to cotangent x. So the red graph is the reciprocal of a tangent graph. Looks very similar, but it looks like it has been reflected. Domain. So it looks like for cotangent, domain x can be any real number, except that we have an asymptote at every pi, and 2 pi, and so on. So x cannot be equal to h pi, assuming that h is an integer. Range, there are no restriction for range. It's going up and down fully. So range y can be any real number, no restriction. Is it even, odd, or neither? So as you can see, it's definitely not symmetrical through the y-axis. And if I were to do the double flip through x and y-axis, it's still not the same. So therefore, it's neither. Do I have any vertical asymptote? Yes, we have a vertical asymptote. X is equal to h pi, assuming where the h is the integer. Do I have any horizontal asymptote? No, there are none. Do I have any minimum or maximum? No, it looks like the graph is going up and down continuously, so there are none. Now what about the period? It looks like the graph, the cotangent graph, is happening every pi. So same thing as a tangent, the period is pi. Okay, now we are going to practice the transformation of graphing when everything is combined. We have in front of us y is equal to 2 cosecant 2x minus pi over 6 plus 1. First step is to identify all the characteristics. Amplitude. So amplitude, in this case, it's undefined. Why? Anything that is reciprocal is for amplitude, it doesn't matter. Okay, because there's no maximum or minimum. So amplitude is undefined. Period. So it looks like k is 2. So the period formula is 2 pi over k, or b, and 2 pi over 2 is equal to pi. Now, are there any phase shift? So yes, there is a phase shift. So I have negative pi over 6. If I were to take it out of the bracket, it becomes positive pi over 6 to the right. And then what is the equation of axis? Yes, there is y is equal to 1. So once we know all this information, let's label the axis. So we have axis over here and axis over here. Now, same thing for sinusoidal and tangent. It's important to know how the graph of the cosecant is going to look like. So roughly, if I have to draw the cosecant graph, it's going to look like this, and this, and this, and that. So there is asymptote at pi, 0, and then we have an asymptote at pi, and an asymptote at 2 pi. So that's m1 and -1. So those are the key points that I want you to understand before you graph anything. So first, let's label. I'm going to do it in different color. So let's do it in black. Let's label the axis of equation of axis, which is at 1. At 1, we have equation of axis. Then we have a period. So it looks like the whole cycle is going to happen at pi. So that means I'm going to divide it into 4 sections again. So instead of writing the one cycle as 2 pi, one cycle is going to be pi and pi over 2. So that means the vertical asymptote is going to happen at pi and at 2 pi. So right in the between. Okay. Now after, then you have to label all the points. So as you can see, it looks like the phase shift. So we're going to do the phase shift later. At the minimum point over here, it's not technically a minimum, but at the turning point is at 1. But the stretch is happening at 2. So even though I said for A is undefined, at 1, it's going to move up by 2 steps. So it's going to be 1, 2, and 3. This is where my starting point for the turning point is. Then it's going curved up and curved up. Okay, so I'm going to write the vertical asymptote. And then there's another, so I have my maximum point of this curve specifically at -1. But because my A value is 2, I'm going to go down by 2 steps from 1. So then it's going to be 1, 2, and 3. Oh, so 1 and 2, 2 steps. So it's at -1. So -1 at this point, and it's going to be downward. Okay, so this is the one cycle without a phase shift. Now let's incorporate the phase shift by different color, red. So we're going to move pi over 6 to the right. So what that means is, assuming that pi over 6 is 0.3, so every pi over 2 is 0.5, 25, so I'm going to be moving this about this step. So we're moving about approximately 0.3 steps. Because the phase shift is pi over 6, I will be shifting everything to the right, including the vertical asymptote. So the vertical asymptote will be shifted to the right by 2, it's about, I would say, 2 steps. Okay, so let's say about here. So this will be pi over 6. And then again, I will be shifting pi over to over here. And then another, we are going to shift pi to the right by pi over 6. Okay, and then I will be moving the two other points, the key points here, same spacing as the equation of axis. So it's going to be 1, 2, it's about here. And then going like this. And then same thing, I will be moving 2 steps. 1, 2. Okay. And it will be going down this way. Okay, so that's how you draw the last third part of the phase shift. So draw everything, including all the transformation, except for phase shift. And then when you're doing the phase shift, you are going to move all the vertical asymptote and the key points to either left or right. Next graph, so we have a cotangent graph. As you can see inside the bracket, it's not factored. First step, let's factor it. Y is equal to 1 over 2 cotangent. So factor completely whatever it's in front of x, so 2 x minus, so pi divided by 2 is going to be pi over 2 minus 1. Okay, so let's identify all the characteristics. So amplitude in this case is undefined, so it doesn't matter because there's no max or min, but keep in mind that 1 over 2 is going to affect where your turning point is going to be located for each curve. And then for period is 2 pi over b, which is in this case 2. So we're going to, but it's cotangent, sorry. So cotangent originally is going to be pi for 1 cycle. So then pi divided by 2 is just pi over 2, okay? And then there is a phase shift. So phase shift, it looks like from a factor form, it's going to be pi over 2 to the right, okay, positive. And then the equation of axis is the y is equal to -1. Now keep in mind, you do have to remember how the cotangent is supposed to look like. So there is a asymptote at every pi and 2 pi and at 0, so it's going to look something like this. This one and this one. Okay. Okay, so now that we understand, let's draw the axis. And it looks like my middle ground, the equation of axis is going to be -1. So I'm going to label -1. And this is my equation of axis. And let's label all the asymptote for the vertical asymptote. So vertical asymptote, so we know that the period is going to be pi over 2, 1 cycle. So I'm going to divide it into 4 sections again. 4. So this is pi over 2. And half of pi over 2 is going to be pi over 4. And half of pi over 4 is going to be 1 over 8. So it's going to be pi over 8 here. And then three pi over 4. So let's draw the points and without a phase shift. We know that the x-intercept is going to be pi over 2. So same idea, at pi over 2, which is the end, this is where the vertical asymptote is going to happen. And pi over 4, vertical asymptote. And 0. So at pi over 8, this is where the axis of the 0 is. Okay, and it's going to be this way. Okay, and then at 3 pi over 2, it's going to be this way. Okay. Now, so we do have to incorporate, so we already incorporate the equation of axis and the period. And for amplitude, in this case, it's going to be undefined in this case. Okay, but what you could do is you could plug it in, and because it's half, it has been, we usually say if it's amplitude, we don't define it for cotangent. And now what we're going to do, we are going to do the phase shift, which is pi over 2 to the right. So for pi over 2, I'm going to do it in everything has to be shifted to the right by pi over 2. So in this case, we have our first asymptote at pi over 2. same thing. And everything is going to be shifted. So again, by pi over 2. 1, 2, 3, 4. So this is going to be pi. And then we have 3 pi. No, we have 3 pi over 2. So this is where the asymptote is going to be, at pi and at 3 pi over 2. Okay, now we are going to let's shift all the x-intercepts to the right by pi over 2. So this pi over 8 is going to be located over here. So I'm shifting to the right by, it's going to be curved up here this way and here. And this point at 3 pi over 4 is going to be located here and this way, going down. So that is the final graph of cotangent, including all the transformations.